Okay, thank you for the reminder. Today we will continue our course about database system. And exactly today we will talk more about the conceptual design or data modeling. It also means that today we will start to do some design data scheme using tools as I mentioned in the WhatsApp group. So make sure you install the tools in your computer because you may need it when you work on your assignment. Okay. Okay, and also please resend the presence code in the chat whenever your friends joining in this room. Okay. Okay, let me continue. Maybe before we continue, I want to do some overview or review, a bit review about our last meeting course. In the last meeting course, we will talk about entity, and then you have assignment to identify the entity along with the characteristic or attributes. And after that, you have to mention the relationships between one entity with the others. And I think that I haven't explained more about the data types. So today I'm going to start with it. Oh, wait. It is a bit lag in my computer. Okay, great. As I mentioned previously in our last meeting that each entity must have several attributes which can describe the characteristic of these entities. And for each attribute, it contains a specific domain that also restrict the value that can be inserted into the attributes. And after that, each attribute also can be represented using a specific data types. So there are several data types that can be used to represent our attributes such as numeric, text or string, date, and also BLOB or blob. Let's move to the numeric first. This is the several data types that can be used to represent numbers in our attributes. For example, it can consist of tiny integer. I think that I did some mistake in here. It should be I, okay, TINY. That must be that's the correction. Tiny integer. It means that this data type can be used to store numbers, but in let's say in the smallest size. In this case, it only consists of 8 bits. So the range of the integer is around minus 128 until 127. This is for the value. And the bigger one is small integer. It's also used to store the same data attributes. However, it has a more wide range. Okay, let's say it may have size. It may have size of around 2 bytes or 16 bits. And then medium integer, big integer. And if you want to store not integer, let's say you may store a decimal number, you may need to use float, double, or decimal. Okay, you may use float if the single precision of positive and negative integer value. Let's put this for the example. It may have size around 4 bytes or 32 bits. However, if you need your precision to be more exact or to be more precise, so it means that you have to put double in your data type. And besides that, we can also use decimal. In this decimal, we can also set the number of digits after the decimal, what we call it, after the comma, okay? We call it as a decimal. It can store number within 16 bytes or 128 bits. So the range must be the largest, okay? And then the second data type is text. It can be used to store text or string. there are several data types. For example, char or character. It can be used to store fixed size string data. So it means that the length of the data can be predefined. Let's say if you want to store a data about student number or NRP, and your domain said that NRP must consist of 10 digits of string or 10 digits of characters. So you would be better to use character instead of varchar. You would be better to use char. In the char data types, we can also set the length of the string. If we want to store student number, so the data type must be char, and then let's put 10 on the length size. Okay. I'm going to give you the example. Here's for the example. Char 10. Okay. That's how you can initiate the data types char into your attributes. Okay. If we define char with the length 10, so the valid value must be in the 10 digit. In case you put only 9 or even less than that, so your database will let's say will forbid it. Okay, it won't store your data. Okay, and the next one is varchar. Varchar, we can also set the length of the varchar. However, the main differences is in the chart, the length must be fixed. However, in the varchar, the length is more flexible. So if we say that we have data type like this, varchar 20, for example, so means that the valid value that can be stored in your attribute must consist of at most 20 digits, at most. In case if you only insert, let's say 10 digits of characters, so it will be okay. Okay, the database can accept it. However, if you put the value more than 20, you have more than 20 digits of string, so the database will avoid that too, will give you a warning, so it won't store your database. I'm sorry, it won't store your records. Okay. And after that, we also have tiny text. Tiny text has same characteristic as varchar. Even the range or the length of the digits also the same. Okay. It can consist of at max 255 characters. And after that, we have text. Text have more length on it. Okay. At maximum, it can consist of 65,000 something of characters. And medium text, and the last one is long text. The main idea is please use the more efficient data types. Let's say if you can store your value just within 10 digits, so please use that length. Okay, please don't use too much length because it will consume a lot of more space, rather than if we put the more minimum length size. Okay, and the third type of data types is a date. Okay, date can be used to store a value in a date format. We have a date time, which is the combination of date and time. And then we have year, and also the last one is timestamp. Let's explain one to the others. The first one is date. We can use this to store the date value. It can be in the range of, it start with what we call it, Y, MMDT. So it must be consist of 4 digits of year, followed by 2 digits of months and 2 digits of days. Here's for the example. It can start from year 1000 until 9999. Okay, this is for the range. And the size, it can be in the 3 byte size. This is for the physical value, right? This is for the size of the data when we store it in the physical storage. And the next data type is time. It's quite different with the date. If in date we can store the date, the date means that the day, month, and the year. However, in the time, we can use it to store the time value. It has this format, okay? Hour, minutes, and second. And the range can be shown in this column. It also has 3 byte size to store for each data or each value. Next, we have date time. Date time is kind of a merge between those two, date and time. So the format must be in this string. Year followed by month, followed by days, and after that, it would consist of hour, minutes, and seconds. Okay. However, for the size of the value, it's bigger rather than date and time. It contains around 8 bytes size. Okay. Next is year. As we know that year can be used to store value of year. It must consist of only 4-digit numbers. Start from 100. Start from 1,900 to 2,155. This is for the maximum value of the years itself. Okay. And the size is a bit more efficient. It only consists of 1 byte size only. As we know that it just has 4 digits on it. If we compare it with the if we compare it with the date format, which is more let's say more complex, so we can see the difference of their size. Okay. And the last one, it is the most complex rather than the others. We call it as timestamp. It's just like a date time. However, we also need to put the time zone code. Let's say here's for the format. Start from the year, followed by the month, and then the date or the days. And then we have hour, minutes, and the last one is second. However, we can put the UTC, or we also call it as the time zone of this time. Okay. Okay, we call it as a timestamp. It's more precise rather than the date time. As a result, it also needs more bigger space for the storage. For each value, it needs around 7 until 13 bytes. Okay. Here's for the date. And the last one is the LOB. In case if you want to store value in the other format, it's not like text, it's not like a date or even a number, but it can be in the form of file or audio or even video. We can use this data type. There are 3 kinds of block, which are tiny block. It has more smaller space on the range. Sorry. And then we have a medium block, and the last one is long block. For the description, it's a kind of data types to store large binary object that containing a variable amount of data. As we can see that each file can be divided into bits or binary data. That's why the block can be used to store that kind of format. Values will be treated as binary strings, so you don't need to specify the length while creating this column. You don't have to put the maximum size of the data type, so you just mention it plainly, okay, like this: tiny block, medium block, or even long block. Okay, it really depends on your situation. It really depends on your needs. In case that if you want to store a big file, let's say it's a kind of video, maybe you may consider to use long block rather than tiny block. However, if you want to store a kind of images or pictures, you may consider to use tiny block or medium block. It really depends on your situation or your data source. Okay. So based on this explanation, now we know that we have four main types of data types, which are numeric, and then string, and then jet, and the last one is blob or blob. Okay. Maybe I want to review some about the attributes. Okay, this one. Let's put an example. In case that we have an entity called lectures, lectures has several attributes such as name, address, phone number, email, and so on. And if you ask to put data types on each attribute, what will it be? For NEP, what is the most convenient data type that can be used to store NEP? Any idea?
Maybe char.
Char. Okay, that's good. And for the length, it's really depend on your data. If the length of the NEP code consists of around 16, maybe let's put 16 on the length. Here for the example. And what about the email? Any idea? In your opinion, what the data type of email? What is the data type of email? Anyone? Can we use char in these attributes to represent the email? Can we use char like this?
Maybe varchar.
Varchar? Yeah, varchar. Varchar seems to be more convenient to store email since there's no specific length of each email. My email may be longer than yours. So in this case, it would be more preferable that we use varchar rather than character. Okay. Let's put varchar. Wait. And how about the maximum length? Shall we put 1000 in here? What do you think?
I think the maximum is 255.
255, maybe that's the case. Okay, thank you. Let's say 1000 is maybe it's too long. We never found an email address that consists of 1000 characters, right? Maybe at maximum it's no more than 100. Maybe. I'm not sure either. But as far as I can remember, it cannot be. I never found a specific email consists of more than 100. If that's the case, you would be more preferable to use 100 rather than 1000 because it can reduce the store space, okay? The storage space. And how about the phone number? What is the data type of the phone number? Maybe you have opinion about that. Anyone?
Varchar 12.
Varchar 12, okay. That makes sense. If I ask you, why don't you use number? Why do you use varchar instead of number?
Because there is no var integer.
I'm sorry, could you please repeat?
Because there is no var integer.
Because there is no var integer. No.
Or this integer does not have any restriction like char.
I see. I got it. Okay, thank you, Yusuf. Yes, that might be the reason. Because in the phone number, it can consist of any length, right? maybe if we put our phone number, it can be consist of 12 digits of number. But if we put our home phone number, maybe it will be shorter. However, why don't we use number? Because in number, if we put a number data type to represent a characters, in the future, it can be calculated. It means that this value will be treated as a number, as a mathematical symbol. So it could be added, it can be multiplied, it can be used to process further. However, if we put varchar in this phone number, so the length or the phone number must be a little bit meaningless rather than the previous one if we put number. In case in the future, we won't calculate the phone number of all of the students. That's not the case. So we just want to know the digit or the string of the phone number, student phone number. So it will be more convenient to use varchar rather than number. Okay. So let's say put varchar in here. Maybe to be safe, we can say at maximum 15 length of character. Okay. And let's say, how about the entry year? Do you have any idea? Entry year? Anyone? What is the data type of entry year?
Year, maybe. Year.
Year, maybe? Yeah, you can use year. Or if you cannot find year in your DBMS, because not all of the database management system will have year data types. Is that the case? You also can use integer. Year or integer, both are same. Okay. And what about what else? Do we need block in here in these attributes? Is there any attributes that can be represented using the LOB or block? No, I don't think that we have one. However, if you put another attribute such as photos or the profile picture, let's say profile picture, maybe you may put block in here, okay, to store the file. Okay, that's just the case. Okay, and how about date? Is there any attributes that can be represented using date in this case? I don't think there's one. Okay, maybe in the next slide. Credits, schedule, day. I don't think we also have one too. Except in here, we will have time to represent the time. And this one we also have time maybe. And for the day, how about the day? Do we have to put date on it?
No.
Yes, Fatih, maybe you have opinion.
No. Maybe just use char.
Okay, I'm sorry, could you please repeat that again?
Just use char.
Use
Char.
char or for char?
Char. Just char.
For char may be convenient because the example of data must consist of Sunday, Monday, Tuesday, Wednesday. We don't know what is the exact length of the text. So it will be convenient to use for char rather than char. Let's put for char. Maybe no more than 10 for the length. What is the longest value of day? Saturday? Saturday. Okay, less than 10. So it will be safe if we say that the maximum length of the day can be 10. Okay. Okay, that's how you can consider the data type of each attribute. Please make sure that each attribute must have data types. Okay, and each attribute cannot be consist of 2 or 3 or more data types. You only have to choose one and the only one. Okay. Okay. Okay, I think that's all. Do you have any questions so far before I continue to the data modeling? No? Okay, everything's clear. And then let's move to the conceptual design and data modeling. After you know how to identify entity and you know how to describe the characteristic of entity using attributes, and after that you can also can identify the relationships between one entity and the others. And now let's move to how to model those three elements into one diagram. We call it as a data modeling. In this course, covered conceptual design, we will try to build a model. We call the diagram as conceptual data modeling or CDM. And in this, to do this one, I have to ask you to install the Power Designer as I already mentioned in our WhatsApp group. So please make sure to install that tool in your computer. And then we will cover some course about how to identify table, how to identify the attributes. However, these two is quite similar with our previous course about how to identify entity. That's also similar. And then how to define the key attributes, and then how to define the cardinality of the relationships. These five materials will be covered in today's meeting. Okay, let's start. The step how to design the database can be consist of these three steps. At first, we have to identify or we have to build the conceptual design first, as it can be more abstract, it can be more general, it can be represented using a notation. We will, I will gonna give you some introduction about the symbol, how to use, how to model an entity, how to put the attributes on this entity, and so on. We call it as the conceptual design. And after that, the conceptual design could be breakdown or could be decomposed into more detailed design. We call it as a database design. And the more detailed one is physical design. It means that this diagram is more closely to the physical form of our database in our DBMS. Okay, that's the phase, that's the step how to design the database. Start from the more abstract, we call it as conceptual, and it can be decomposed into more detail, we call it as a database design, and the most detailed one is physical design. In the conceptual design, we will have a CDM diagram, and in the physical design, we will have PDM diagram or physical design model. Okay. In the conceptual design, it may consist of three main steps. Before we start to model our database using those tools, we have to know first, we have to understand the business requirement of the system first, or the process business of the system. As we already know from our previous meeting, before you can identify such and several entity, you have to create a narration. You have to create the storyboard of your system. This is also the step, this also represent or the implementation of the investigation step. Using those narration, we can identify the business requirements or even the data items of the system that can be stored in our database. That must be the first step. And after that, The next step is to create the data model. After we can identify the business process and also the data items, what kind of attributes that can be stored in our database, later we can start to do some modeling. In this step, you will design those data items into one whole diagram. We call it as a data model. Data model is also the representation of data transaction in business process. What kind of data that will be processed and will be stored in our database. In this step, the output must be in the CDM diagram. Sorry. I'm sorry for the interruption. And the last step must be verification. After we have a whole model, a whole design of our database scheme, the last part is to do some verification. In this verification, we will test the data model. We will create several scenarios, and then we will put some dummy data into it. And we have to make sure whether our database model can store those data or not. Okay, that's what we do in the verification. It mostly the goal is for verify the business requirements with initial data model. After you do some verification step, maybe you need a further revision of your data model. This step can be returned to the previous one. So you have to revise your data, and then you have to do the verification again. That's how you can create your data model. Maybe it may need two or maybe three increments to do that. Okay. In the conceptual model, we only focus on how to build the concept based on the business needs without considering what kind of database management system or what kind of hardware that we will use in the future. We call it as a conceptual design. It's more general, it's more abstract. It is also independent with the software or the hardware. Okay, maybe I'm going to give you a brief overview about the DBMS. The example of DBMS, for example, we may use Oracle or even MySQL. This is the example of database management system that are well known. Okay, and then we may have PostgreSQL, or even Access, maybe. Okay, that's the example of the DBMS. However, in conceptual design, you put this aside. The conceptual design can be implemented in any kind of DBMS because it's more abstract, it's more general. It only consists of a concept, not for a technical use. Okay, that's why we call it as a conceptual design. Wait. I'm sorry, I'm going to wait for 2 minutes. There is some interruption.
Sorry, 3 months.
Okay, great. Okay, we call it as the stepwise refinement. It means that the output from those steps could be the input of the next step. However, it could be revised. Okay, so the model will become better and better. We call it as stepwise refinement. And if you wonder what is the output of the conceptual model, it could be like these two diagrams. We will know these two types of diagram. The first one, we call it as ERT diagram. entity relationships diagram. And the last one is the conceptual data model or CDM. Maybe I'm just going to give you this brief explanation about ER, but mostly when we do some modeling database, we use CDM rather than ER. Okay. However, in this course, we will cover these two. Okay. In order to build this kind of diagram, you need to install Power Designer as I already shared in our group. Okay. Let's move to the next slide for the conceptual design. Conceptual design is used to describe in detail the database structure in a logical form. It means that we have to remodel our concept about the data items. It could be represent an object, it could be represent entity, and each entity has several characteristics. We call it as a conceptual. This structure is independent to any software and particular data storage structure. So when we do this step, we neglect any kind of GBMS because we haven't described it yet, okay? The component of conceptual design consists of these 4 elements. As you can see, maybe 3 of those you already know 3 of those in our previous meeting. But that's fine if we do some review of it. Let's say entity. Entity can be used to represent object or event. It could be something that we can touch, we can see, we can hear maybe. However, it also can represent such an event or such an abstract concept. Let's put a course for the example or department for the example. Jobs maybe, that's also an abstract concept about something. We can use this as an entity. In addition, the entity or this object can be distinguished with the other. So it means that between one object with the other has their own characteristics. Okay? However, for the attributes, as you already know that for each entity can be or must be described into several characteristics. We also call it as attributes or properties. The data items that describe the characteristic of an entity. For example, if we have student entity, it may have several attributes such as NRP, name, date of birth, and so on. And the third one is relationships. It can represent the relation between one entity with the other entity. For example, the relationships between lecturer and students that can be represented as supervised. One lecturer can supervise many students. We call it as a relationships. Okay. And the last one, maybe you never heard it before. It's about the constraint. Constraint is also can be considered as a limitation. Okay? It used to ensure the data integrity. For example, constraint avoids errors when inserting or deleting data. I'm going to talk about that later, okay? About the constraint. Let's hope that we will have the, okay, maybe in the next slide, we will have some example about the constraint, okay? And here, there are several terms that you need to know. In the conceptual, we know, we will describe an object as an entity. We call it as an entity. We use term entity to represent specific object. However, if we move to the next step into physical model, we call it as a table. Okay, there are the differences of the term used between those two different steps. In the conceptual, we call characteristic as attributes. However, in the physical, we call it as the column or field. Okay. In the conceptual, we call record or data as a tuple. However, in the physical, we call it as a row or record. There are some maps of terms. This is the mapping of the terms between conceptual design and the physical design. Okay. Okay, let's move to the entity. Entity is an object or event happens in the real world, which can be distinguished that object among the others. This object must be unique. For example, we can distinguish between students and lecturers, or maybe lecturers and teachers. We can also distinguish between lecturers and classes, maybe we call it as an entity. Okay. Entity must have attributes that can describe the characteristic of this entity. And for the notation, for the symbol, in the ER diagram, we use this, what we call it? We use this, it's not a square. Okay, we use this symbol to represent an entity, and also it has a name on it. Okay. However, in CDM, conceptual data model, we will use, let's see, okay, this one, to represent an entity. It consists of 3 compartments. The first compartment, it mentions the name of this entity. And after that, the second compartment consists of several attributes to describe that entity. And for the last one, consists of several constraints such as primary key. Okay, we will talk more about that. Okay, this is how you can represent an entity in the CDM, conceptual data model. However, in ER diagram, you may use this symbol. Okay. Okay. If you found this kind of attribute that has underline on it, or maybe has a bold on it, it also means that this attribute is considered as the primary key of the entity. Okay. For example, entity student has several attributes such as NRP, name, date of birth, telephone number, and email. But as we can see in the NRP has underline on it, which means that the NRP is the primary key of this entity. Okay, that's how we represent a primary key within an entity. Okay. However, in conceptual data model, this also the other type of notation. We can use this one like this, or even like this one. Okay, that's up to you. Okay. However, in the Power Designer, we use this notation rather than this one. I forgot the tool that used to model this one, but in a more common case, we mostly use this diagram using Power Designer. Okay. Okay. Maybe I'm also going to give you some demo how to build an entity in a Power Designer. Okay, it takes some time to for the Power Designer to be started in my computer. Okay, let's move to the slide first. Okay. There are several types of entity. We have 2 types of entity. The first one is strong entity. As we know from the previous meeting that the strong entity has their own primary key. They don't borrow the primary key from the others. Okay, we call it as a strong entity. It is an independent entity to the existence of the other entities. Their existence is independence with the independence to the other. For example, we have a strong entity lecturer, as we know that the lecturer may have an IP or lecturer number or maybe lecturer ID, as its primary key. So we call the lecturer as the example of strong entity. The opposite of strong entity must be weak entity. In the other words, the weak entity, the existence of the weak entity is really depends on the others. This entity use the other entity's attribute. Let's say they use the other key, primary key, to present their to present their primary key. We also call it as a foreign key. Here's for example, we have two entities. The first one must be the strong one, since lecturer has its own primary key, which is an IP. And then lecturer has relationship with the dependent. Dependent in Indonesia we call it as tanggungan, ya, tanggungan anak, maybe spouse atau suami atau istri. Lecturer has dependent, and then since the dependent doesn't have any dependent ID or dependent number, so the entity dependent must borrow an IP as its primary key to represent several data on it. Okay, and the existence of dependent data really depend on the existence of lecturer data. Let's put myself for the example. If there is a lecture data mentioned about my name, and then it also has relation to many records on a dependent, in case maybe in the future I resign from the lecturer job, so it means that my data will be deleted from the entity. It also can process to the deletion of several dependent record that has relation to my data. Okay, that's why we call dependent as the weak entity. Here's for the explanation. In the ER diagram and the relationship diagram, we represent the weak entity with this square, but it has a double line on it, like this. Okay. But in a strong entity, it only have a one or single line on it. That's the differences between strong entity and weak entity in the ER diagram. However, if we convert those ER diagram into CDM like this, there's no difference between strong entity with weak entity, since both of those entities represented using the same notation. We cannot see a double line on it. However, the weak entity in the ER diagram can be converted into weak relationships in the CDM. Let's put this. This is for the ER diagram. This is for conceptual data modeling or CDM diagram. In CDM, this weak entity will be converted into this dependence relationships. It has a specific symbol on it. Okay, like this. Lecturer and so on. Okay, maybe I can move to the Power Designer. Maybe I need to share my screen. Okay, share screen. Can you see my screen now? Okay, great. At first, after you start your Power Designer, it will give you this dialog. In order to create a new model, please choose the Create Model in here. And then the direct will give you some options. There are several model types that can be built using this Power Designer. However, since I want to create a CDM diagram, so I will choose conceptual data model in here. Okay. Another that you can put your model name. Let's say academic. the academic or anything else. It's up to you. Okay, conceptual design, and then press OK. Okay. In this diagram, we call it as a workspace. By default, it's still blank, it's still empty. If you want to create an entity, you can use a toolbox on your right side in here. Make sure you take a look at the conceptual diagram group and please find the entity symbol like this. Click the symbol and then you can notice that your cursor in here is converted into this icon. And then please click into the empty space like this. Okay. By default, it already has a name on it. The first square, it has name entity 1, but we can also rename it later. Okay. I want to give you some practice about creating a lecturer. I'm going to use this one. I'm going to use this example. I want to convert this ER diagram into CDM diagram. So I will create two entities, lecturer and dependent. In the lecturer, I'll put some attributes such as NEP, name, address. Maybe we can put the other attributes later. And in the dependent entity, we can put several attributes such as dependent name, sex, date of birth, and so on. Okay. I'm going to return to the Power Designer. The first one, please make sure to click this pointer. So your pointer will be will be transformed into the more standard pointer like this. And then double click to one of the symbol. In this case, I want to give its name with lecturers like this. Okay. You may use you may use a capital L, or even for the more convenient, you can use a caps lock like this. That really depends on you. But in my case, I would be more convenient to use caps lock. Okay. But it really depends on your preference. You may use a caps lock, you may use uppercase. That's really depend on you. That's fine. Okay. And for the attributes, I will put an EP. Sorry, like this. And then I'll put the name, the lecturer's name. In my case, I will be more convenient if I put the first letter of this entity in the first digit. Let's say L for the example. L name means that this attribute represents the name of lecturer. Because in the other case, we may have the name of dependent. So in order to distinguish between the name of lecturer and the name of dependent, in my case, I would prefer to put the the uppercase letter in the beginning of the attribute. Okay. And after that, I'll name LDOP maybe, or date of birth. What else? Email maybe. Phone number maybe. Text maybe, and so on. Okay. And after that, you can choose the data type of each column. For each field, like this. For the NEP, since my lecturer number consists of 16 digits of numbers, so it will be more convenient to put variable characters for the data types. And then I will put length 16 as the maximum length of the, I will put characters I'm going to use characters rather than variable characters because as far as I know, the digit number of NIP always consistent. My friend also has the same length of digit NIP. And also my other friend from the different universities, they also have the same length of NIP. So I thought that maybe that's the rule for the NIP, that's the domain for the NIP. In this case, I'm going to use characters rather than variable characters. Okay. And for the L name, you can use variable characters. You can use any length, but make sure that there is the maximum length of your possible data. Okay. In my case, since I will not find any lecturer's name that has more than 100 digits. So I'll put the 100 as the maximum length of the lecturer's name. And for the date of birth, what's going to be? What is the data types of date of birth? Anyone?
I think it could be
Date. Okay. How about the others? Shall we put date time in the date of birth? How do you think?
No, I think that is enough, sir.
It's not necessary, right? It's unnecessary to put
Yes.
time on our date of birth because, yeah, we never asked to put our time. Maybe just for the date, okay? Okay, that's
Yes.
great. Let's put it for the data types. And then for the email, we can also use the same data type as in the name. Okay, let's say 100 for the maximum length. And then the phone number. Let's put 15 maybe. And nah, how about for the sex or jenis kelamin? What is most proper? What is the most proper data type?
char.
Char. And what is length?
I think 1 is enough.
Okay, 1 is enough. Maybe you want to distinguish between female and male only, right? F and M
Yes.
only. Okay, if that's the case, this is more convenient to use character with 1 length of digit. Okay. However, we can also put some constraint on it. Let's see. Oh, wait. Before we can put more constraint, which means we can put more limitation on each attribute, we have to apply it first or save it first. Okay. And then we can double click on this character. What I'm going to do is I want to put some limitation on these data types. So the valid value must only consist of F, female, or M only. There's no other value. We cannot put A, we cannot put B, we only can put F or M only. Okay, if that's the case, you have to explain your constraint in this diagram. In order to do so, double click on the column like this. And then, okay, let's move to the next step, which is standard checks. In the standard checks, we going to ask for the list of value for the limitation. Okay, let's put M. And for the label, it can represent male, and F, which can represent female, like this. Okay. Mixed case, uppercase. Okay, let's put uppercase. If it's mixed case, it means that we sometimes we put M. It also can be considered to true. But if we don't want that to happen, make sure to put the uppercase characters. Okay. And okay, maybe there's the case that your client or your database user put it blank. Okay, put it blank, insert blank value on the text column. If that's the case, you can set the default value of that attribute. Let's say if I want to put male as the default value of the text in the lecture text. In case that the user did not describe or did not input any value on the text column, your DBMS will add M in the column by default without you ask. Okay. Okay, we call it as the constraint. Okay, like this. Don't forget to put OK or apply. Wait a minute. Let's take a look. Okay, it's already saved in the model. No rules. Okay. Okay, that's fine. Okay, great. And even you cannot notice the differences, you cannot notice your previous setting, that's fine. As long as if you double check or double click in that column, you can make sure that your setting is already stored in the model. So that's fine. Okay. Great. Now, and how about the primary key? What is the primary key of the lecturer? Which one should we put as the primary key? NIP, name, DOB, email, phone, or what?
NIP.
I
Yeah.
think NIP.
Yeah, I think an IP is more convenient. Okay. As we check the P icon, you can see it can be used to set the primary identifier. Primary identifier is represent the primary key. Okay, representing the primary key. However, for the M mandatory, it means that this column cannot be null. We cannot put a new record without insert the NIP value. We call it as mandatory. Harus ya, harus diisi. Okay, we call it as mandatory. For the column, for the primary column, by default, the mandatory will be checked by the Power Designer because there will be no record who doesn't have a NIP. Sorry. If there is a case that your other attribute cannot be null, let's say you cannot insert a new record of lecturer if it doesn't have name on it, so you should put mandatory, you should check mandatory on this column also. Okay. However, if you also think that the email must be inserted in the new record, you can also check this mandatory. Okay, that's how you can put constraint. Constraint means the limitation that makes sure that your data must be valid before inserted into the DBMS. It must meet the format. It must meet the requirement that you already defined in the beginning. Okay, that's why we call it as a constraint or limitation. Okay. If I put apply on it, you can see the differences in the model. As you can see, the attribute of NIP now has underline on it. Okay, NIP has underline, and also you can notice there is a PI. PI means that this column also has a role as a primary identifier, like this. Primary identifier, PI. It means that this column also considered as the primary key of lecturer entity. Okay. If you already decide the primary key, now you can see in the third compartment, it will have identifier 1. So it means that your entity already has a primary key. Okay. Okay. Let's put OK. Now We want to create the second entity, which is dependent. Dependent represent the dependence that has relation with the lecturers. It can be in the child relation or maybe spouse relation, husband or wife, and so on. Okay. Let's do the same step as previous. Let's double click the entity symbol. And after that, you can rename your entity dependence. Okay. Oh, let's put S on it. Okay. Now for the dependence, we put several attributes or columns of from the entity of that entity. Dependent name. Okay. And then maybe dependent DOP, dependent text. And the last one is the relation with the lecturers. Okay, I put relation on it. Okay, and then for the name, what shall we choose in these data types that can represent the name of dependence? Which one? Any idea? Which data types?
Maybe varchar.
Varchar. Okay. Let's put 100 like this for the variable character or varchar. And then, okay. And for the DOP, it also has the same type as previous. We can use it. And then for the text, okay, so you have the same one like previously. However, if you already know that the rule of the sex column must be char1 whenever you put those characters, whenever you put those columns in the lecturers or dependents, or maybe you will have the third entity called student in here, and it also has a sex column on it, and you decide that all of those sex column must describe with character 1 only. So it means that you already have the rule, you already have the default constraint for any sex column. It will be more convenient to use domain. Okay, let's see. In this case, I'm going to setting the domain in the LSEX first, and then I can reuse those domain in the other columns in the different entity. Okay, let's put in here LSEX. I want to use a specific domain to represent the sex, jenis kelamin. I'll create one domain. Sorry, I cannot. Oh, okay, I'm sorry. I made a mistake. Okay, let's use this one. Choose a model menu and try to find domains on it. Okay, in the list of domain, let's create a new domain. Oh, wait. Yes. Okay, let's give it name text domain. Okay, text domain. And for the standard checks, let's put the settings on the previous LSEX. Let's move into this one. As a default, let's put M in here. And let's put uppercase for the value. It's M, which is represent a male. And then F, which is represent female, like this. Okay. Update checks. Okay, I'm sorry. Yeah. No rule. Okay, great. If you put mandatory on it, so all of your sex column must be inserted by the user. It cannot be null. However, if you uncheck these mandatory settings, so maybe in the other column, it can be null. It can be left blank, okay? You don't have to insert the text value. That will be fine also, if it's not mandatory, okay? Okay, let's say, okay. You have modified, select the properties you want to update. I don't want to put this one, okay? I'll make sure that the mandatory is unchecked and the standard check is already stored. Okay. Okay. Now we have one domain. Domain means the standard constraint that can be reused in several columns, which has the specific, which has the same rule, which has the same integration rule on it. Okay. And after that, we can set the sex into a sex domain. Okay. Let's double click the entity lecturers and move to the attributes tab on the LSEX column in the domain. Choose sex like this. Okay. Now we will have a sex data type, which is also represent the domain of the sex. It must only can contain of two options, F or M only, and by default, if your user, if there is a new insertion of data that doesn't have a sex value on it, your DBMS will put M on the column of the new record. Okay. Here we go. And since we already defined the constraint about sex, how we can insert a sex value on each entities, now we can reuse this domain in the different entities, in the others dependent. I'm sorry, in the others entities. Okay. Let's move to the entity dependent. For the attributes of sex in here, we don't have to do the same settings. We don't have to redo all of those complex settings. We just need to put sex in the domain. Okay, like this. If you have the third entity called students, and it also has the same value. The first one must be NRP, and then I will have as sex for the example. Also can be used the domain. It's more convenient since you can do a simple setting, and the setting can be implemented in all of your model automatically without take a look at one by one entities, without moving from one entity to another entity and do the same setting as you did previously. That will be a very unpractical thing to do. Okay. Instead of using a data type setting, you can use a domain setting. Okay, that's the tips. Okay. And after that, I haven't finished with this dependent definition. I'm going to return to the attributes. For the relation, let's say we have a specific constraint. The relation value can only choose from, let's say, children or child, and spouse only, children or spouse only. We can use variable characters, children and spouse. I think it must be less than 10, right? Like this. Okay. And let's put the apply first. And after that, you can put the setting or put the constraint on the settings. Okay. Like we did previously, we choose child. For the example, the label must be child. So, and then spouse. It represent the same name in the label. Okay, let's use the uppercase. However, you may use mixed case. If you use mixed case, you can put a big C and the lowercase HILD in the following. I did not put default value. Okay, so I left it blank. However, since the relationship must describe the relation between those dependent with the lecturer, one of the record in the lecture, so I'm going to put more specific constraint that this attribute must be inserted. This value must be inserted by the user. It cannot be left blank. It cannot be null value. Okay, so I put mandatory on this constraint. Okay, then. And what about the primary key? What is the proper primary key of the dependence? Do you have any idea? Can we use the name as the primary key? How do you think?
Maybe the relation. I don't know.
I'm sorry, can you please repeat? Can you?
In my opinion, I think the primary key is the relation, but I don't know.
Relation. Okay, if we put the relation as we already decide previously in our step, that we only have two kind of options, child and a spouse. If we set relations as the primary key, so we won't have many records who has an identical option. What I mean was, in my case, if I have two kids, if I have two children, only one of my children can be inserted into the table. My second one cannot be because the data, the relation value is already used child on the first record. So we can put another record who has the same relation value on it. It cannot be, it only can be implement one. It can only be inserted once. Okay. So we don't think that the relation can be used as the primary key. That's the reason. Maybe the others. Do you have any other opinion, Ranga, maybe?
The lecturers and IP.
Okay. The lectures and IP. Okay. So did you mean that the dependent must be the weak entities?
Yeah.
Okay. I got it. I got your idea. If there is no other column that can be used as the primary key of that entity, so we can borrow it from the other from the other entities. As we know that the lecturers has the direct relation with dependents, so we can draw a relationship between lecturers and dependent using this notation, relationships. Okay. Please make sure that there is differences if you draw the line start from the lecturers to dependent. So your relationship must be in this space like this. However, if you do it otherwise, let's see, you can see the difference, right? There has both of those relations have the different meaning. Let's start from the relationship one first. I'm going to delete the relationships too. Okay, if the relationship has this kind of notation, I'm going to zoom in out. Okay, if there is just one line connect to the lecturers, it means that one record of lecturer can have relation to many records of the dependent. Let's put an example. I'm a lecturer. My identity can be stored in the lecturer. I have record in the lecturer's entity. In fact, I have two dependents. I have three dependents. 2 of them are my children, and the others is my spouse. That's for my case, which means that my single record, has relation to 3 records in the dependent. We also notice it as a one to many. One lecturer connect to many dependents. Okay, so the symbol must be like this. In the near dependence, the symbol must be in the fork, like this, fork symbol. So it means that it can be connected to several or too many records in the dependence. Okay, we call it as the one to many. However, if you did it otherwise, like this, it has a different meaning. Okay, one dependent can have connection to many lectures. It doesn't make a sense. Okay, as we can see, one of my children can only have relation to my records only. It cannot have it cannot have relation to my friends maybe, or to my head department. No, it is forbidden. That's why this relationships is cannot be used, because it represents one dependent has relation to many lecturers, and it did not represent the fact. Okay, so we can delete this one, or we can choose the settings. Okay, we can change the setting of the relationships. Okay, the way to use that, the way to do that is double click the relationship symbol, and then move to the cardinality step. In this cardinality step, you can choose between one to many or many to one. Let's notice that the entity 1 is dependence. The entity 2 is lecturers. There's also several sentences can be used to give you more comprehensive meaning of those relationships. If we put this symbol, it also means that each dependence may have one or more lecturers, which is invalid, right? Okay. What if we put it otherwise? Let's say instead of choose one to many, I'll choose many to one. Many dependent can have relation to one lecturers only. Each dependence may have at most one lecturer. Each record independence may have relation to one lecturers only. May have at most one. Oh, it means that maybe there's a dependent record who doesn't have a lecture. If we don't want that to happen, just make sure to put mandatory on it. Okay. If we check the mandatory, the symbol, the circle symbol will be transformed into line symbol like this. And you can also notice the sentence also change. Each dependence must have one and only one lectures. In our case, this really represents the fact, as we know that all of these dependent must have lecturer, must have their parents or their spouse as the primary key. That's why it will be more convenient to put mandatory in this symbol. Okay, dependent has one lecturer, at least one, and at most one, must have one. Okay. However, the other sentences also state each lecturers may have one or more dependents. As we can see, one lecturer record may have relation to one or many dependents record. However, we don't put mandatory in this case. Why? Because maybe there's a case lecturer who doesn't have any dependents. Maybe this lecturer is still single, unmarried yet. So he or she doesn't have any dependence. If that the case is possible, so just make sure not to check this mandatory option. Leave it 0 because there, in fact, there may be a record who doesn't have any relation with the record's independence. Okay, that's we call it mandatory. And to make this more convenient, to make this more informative, we can rename the name of the relationships. Let's say has dependent. Okay. That's for the case. Oh, I'm sorry, I forgot one thing. Because in our slide say that dependent is the weak entity, dependent entity doesn't have primary key, so it needs to borrow primary key from the lecturers. To model that fact, to model that rule, we need to do some setting, some additional setting in the relationships. In the cardinalities, check the dependent like this. Dependent means that each record's independence is dependent to one of the records in the lectures. In the other words, it also represent that if the record in the lecturer is deleted, will be deleted, it can also delete several records independent who has relation with the deleted record in lecturer. Okay, we call it as a dependent. Okay, if we put dependent like this, you can also notice that the symbol will be transformed into something like a fork, but it also followed by triangle like this. It means that the dependent records is dependent to lecturers. Bergantung gitu ya. Keberadaan, the existence of dependent records is dependent to the existence of the lecturer's record. Okay, that's how you can represent weak entity in CDM diagram, conceptual data model diagram. Okay. Okay. Now you can notice that in the dependent entity, we still haven't identifier yet, since that entity doesn't have any primary key. I'm sorry, I have to erase that one first because it will create some errors. Okay, I have to, I'm sorry. I have to delete this object first. Oh, wait. Okay. Okay, that's great. Now, this is our class diagram. In the Power Designer, there's also a menu that can be used to check your model, whether your model already fulfilled the rule of the conceptual data modeling or not. We call it as a check model menu. Tools. Okay, this one. You can find the menu in the check model, or for the shortcut, you can press F4 in your keyboard. Okay. In the check model, the Power Designer will help you to check the validity of your model. Okay, automatically. Just make sure to check all of those options and then click OK. Okay, let's see. It will give you several warnings such as undefined data type text, undefined data item NRP. I think that these two columns came from the student's entity, right? Am I right? And also SX, it came from the student entity that I've already deleted in the previous. In order to what we call it, eliminate this warning, we can move to the, let's see, Oh, wait. Let's move to the diagram first, and then in the model, wait, we can start from here. Okay. Oh, if you choose result list, we cannot find the model menu on it. However, if you move to the diagram, we can find model in the feature. Okay, let's put model, and then let's move to the data items. And as you can see, we have several data items that not existed anymore in the diagram. For example, sex, which came from the student entities, we can delete this one. NRP, that also came from the student entities. NIP is already there. LSEX, it used by the diagram in here. Alphone is in here. Email name DOB, all of this already mentioned in the lecturer's entity. And for the dependents, we have 1, 2, 3, 4. Okay, this attribute. So the data item is the list of attributes owned by your entities. If you have a data item that that is unused or that is not implemented in your model, it would be better if we delete that data items. Okay. Okay, then I think that we already do some elimination. Then we can put okay. And please recheck your model. Check model. Okay. Okay, we still have this one. Undefined data type, sex, D, sex. Oh, okay. I missed that one. Okay, I missed that one. Let's move to the domains. Okay, I forgot to put the data types. I forgot to choose the data types. It must be character 1, right? Okay. And then finished. Okay, see the warning now eliminate. Okay, the warning is missing. That's how you can check your model whether it do not violate any conceptual conceptual rule or not. You can use a check model to check your design. Okay, that's how you do that. Okay. Do you have any questions so far? No? Everything's clear?
It's clear, ma'am.
Okay, great.
Excuse me.
Okay, great. Thank you.
Uh,
And if you're curious, so now how about the primary key of dependence? Since we don't have any underline on the list of the attribute, we cannot find there is attribute who has underline in the dependence entity. So what about the primary key? As we discussed in our previous meeting that each of the entity must have primary key, right? But in this case, dependence hasn't any primary key. In order to create the foreign key, which is the primary key came from the other entities, okay, we have to convert this CDM into PDM, physical data model. Okay. What I mean was, in our previous slide, we have 3 kinds of steps: conceptual design, database design, and then physical design. What we done until this point, we implement these 2, conceptual design and database design. However, in order to make it more detailed, to make it more close with technical thing that we want to implement in our database, we have to convert our CDM model into PDM model, physical data model. Okay. We can still use a Power Designer tool to generate our CDM into PDM format. So you don't have to recreate the diagram. No, it's really unnecessary. You just need to press one feature. We call it as a generate physical data model in here. Okay, generate physical data model. Okay, before the tool generate the PDM model for you, you will be asked to choose what kind of DBMS you will use in your PDM. As I already mentioned previously, that the DBMS can be in any kind of a brand. It can be Oracle. We can also choose MySQL or MySQL, or we can use Postgre. We can use Oracle. We can use anything. Okay. In this case, I'm going to use PostgreSQL. Okay. But in your case, you may choose one of them. That really depends on your implementation. Okay. Okay. I'm going to use Postgre for my DBMS. It's it's one of the DBMS that is free. You don't have to pay for the license. It's already free. You can download the DBMS Postgre from the internet, and then you can install it into your computer without paying any license. Okay. Okay, then I'll put the generate new physical model. And now, as you can see, the Power Designer did everything for you. In the previous diagram, in the CDM diagram, we are not sure what is the primary key of the dependent, since it doesn't have any underline on the attributes. After we generate the physical data model, we can see the difference. In the physical data model, the dependent will use NIP as its primary key. But we know in here that those attributes came from the lecturers. As we can also notice in this symbol, it says PKFK. It stands for primary key, foreign key, which means that this NIP attributes independence has a role as a primary key, but that attribute is derived from the other entity. That's why it's also called as the foreign key of the dependent, because those attribute is borrowed from the other entities, PKFK. In the lecturers, they only have one PK because primary key in this attribute is owned by the lecturers. It's already owned by the lecturers because it is a strong entity. Okay, that's the difference between strong entity and weak entity. In the weak entity, we may find this code PKFK, which stands for primary key and foreign key. However, in the strong entity, we only can find one primary key only without any PKFK, something like that. Okay, that's the differences between strong entity and a weak entity. Okay, is it understandable for you, or I explain it too fast? No, everything's clear. Okay, then maybe you have questions.
Hello,
Okay, Fatih,
hello,
please.
ma'am. I have a question. What's your thought on composite key?
Composite key.
Yeah, what's your opinion about composite key?
Okay. What about the composite key? Composite key means that the primary key can consist of several attributes. Is that right?
Right.
Okay. If there's a case that you have several attributes that needs to be combined as one primary key, you can set the primary key in the CDM first. Everything you have start from the CDM first, like this one. And then in the attribute, just check any other attribute that you need to insert as the primary key. As simple as that. Okay. Do you get the idea?
Yes, ma'am.
Okay. That's how you can create a composite key using Power Designer. You just need to check the P option on the CDM. Okay. just like that. However, if the case that I put a, let's say, I put the composite key in here, I put the composite key in here. Let's say I set NEP and name as the composite key, as the primary key. Okay. Now we will have to, we will have a pair of primary key. It must consist of NEP and LNAME. Okay. And then before I generate the physical data model, it would be better if I check the model first using check model tools, or just simply as you hit the F4 button in your keyboard like this. Okay. And make sure there is no warning or even error mentioned in the result list. It means that your model is already valid by concept. Okay. And after that, you have to regenerate your CDM into PDM, physical data model. You can press Ctrl G, or you can use these tools, generate physical model. Okay. There are two options. Since we already built the physical data model previously, it would be better if we use update existing physical data model. So the Power Designer won't create a new model for you, but it will recreate or it will revise your previous version of PDM. Okay. I'm going to put this one, update existing. Okay. It gives you a warning since we already generate before. So the Power Designer needs to confirm whether I'm going to override those, override the previous model or not. Okay. In this case, I just simply put press, I'm just simply press OK. Now you can also notice that in the dependence entity, we have two primary key. We have a pair of primary key as owned by the lecturers. That's how the behavior of a weak entity. It really copied the primary key from the other entities. Okay. Okay. Now you get it? But also make sure that NEP LNAME, it came from the lectures, and the name is the name of the dependent. So we will put more information when we want to insert a new report in the dependence table or dependence entity. Okay, that's how the weak entity behaves in our modeling schema. Okay, now you get it? Do you have any more questions? No, not so far. Okay, great. Since I don't think it's appropriate for our model, I'm going to I'm going to uncheck the primary key in the LNAME. Wait a minute. Okay, I have to recheck the model. Okay, there's no warning. And then I will generate our, okay, preserve modification. No. Okay. Okay. Yeah, it's more appropriate. It only has one dependent. Okay. But if there's case that you have to check the name of dependents, you have to check you have to check there is no the same dependent name in my case. Let's say I have two dependent. Maybe it will be easier if I'm using Excel to represent the data. Okay, wait a minute. Okay, let's say we use this step to store the records of lecturers. This is for the lecturers table. We have an IP, we have our name, our DOB, our email, our phone, our I'm gonna put bold and underline on it to make sure that that's the primary key. And for the example, it consists of 16. Okay. Here's from my NEP. Okay. And I'm sorry. Text. How about text? Oh, wait. Okay. And then for the name, let's put my name. And for the DOP, let's say, oh, wait, I have to. Where is date? Oh, we don't have any. I'm going to use custom. I'm going to use y CD. Okay. This for the phone. Let's say up. Okay. That's the example of the records. Okay. Now, let's say I have three. I'm sorry. I have three dependents. The name, the DOP, the sex, the relation, and it has like this as the primary key. Let's put my NEP. Okay, wait. Okay. And then let's say my dependent names Nina like this. And her DOB, her sex, and so on. Like this. Let's say like this. Now, it also mentioned that based on this record, we know that Nina is my dependent, right? However, if I have more than one dependent, what should I do? Can I insert the exact value in the NIP column like this? Let's say I have my second child. The name is Hannah for the example. Can I insert this record on the DBMS? Can I? What do you think? We know that NEP is the primary key of dependence, right? And we know that the nature of primary key, it cannot be redundant. It cannot be cloned. It cannot be, there's a fact that we have more than one record who has the exact value that already inserted in the tables. So do you think that I can insert a new record in the third one like this? In the third row like this? What do you think? Can or cannot?
I think it's cannot.
Yes or no? Sorry?
No.
No. How about the others? Do you have any other opinions?
It's a no, ma'am.
No. Okay. So all of you agree that we cannot insert a new record who has the same value of NEP? Are we agree?
Yes, ma'am. No.
Okay. Okay then. So since we only have one attribute, which is NEP as the primary key, we cannot insert a new record who already used the value in the NIP column. So it means that our model may be true. It cannot be, it can be implemented. However, it cannot meet the requirements because in fact, I may have some dependence. Okay. In order to do so, we have to create a new primary key, right? We have to put more thing. We have to do some setting to distinguish Nina and Hannah or first record with the second record. Am I right? So what's your idea? What's your idea then? Exactly what we were going to do is a refinement step. Like in here. Like in here. Okay. Now we're going to do the stepwise refinement step to revise our model in the physical design in the PDM. So do you have any idea? Any idea? I'm open to any idea. Anyone? Or you get confused too? So what if we can put one more or maybe some attribute? We can choose between this attribute who's going to be the primary key along with the NEP. Which one will you choose? Name, DOB, text, or relation? Which one?
Name. Yes.
Name. Maybe name. Because in fact, I won't have children who has the same exact name. Even it may be true but it's quite rare, right? Okay. I won't give my children name as the same name as her sister. It's a big no in my case. And I think that's also true for most of people. Okay, if that's the case, we won't find any name dependence we won't find the same dependent name connect with the same NEP, right? Okay, so we can set the D name in here as the primary key. Check the primary key in the D name. Okay. Now we have primary key D name and dependence as the primary key of the D name and NEP as the dependence primary key. Okay. I'm sorry. Okay. How about now? Is that true? Can we do that?
Yes, I think.
Yes, right. Okay, that's how you do the stepwise refinement. Okay, is it understandable for you? Or do you have any questions, please?
Miss, so now the dependence is actually a strong entity, right? Because it has a entity.
Primary key. No. By concept, based on the concept, dependence still considered as the weak entity because the existence of the dependent records really depend on the lecturer's record. And if we put, let's say, if we put primary key in the conceptual model, it means that dependence will be the strong entity, right? Am I right, Yusuf? Yeah. If I set this name in the conceptual model as the primary key, so it won't be the weak entity anymore. Okay, but in fact, I cannot put a new record. Let's say now we have my friends an IP like this. Okay. Oh, wait. Okay. This for the case. And then apparently Bu Adatus has children who has the same name as mine. Okay. Her child name is also Nina for the example. And since we in the conceptual model, we set it as the strong entity which has primary key D name. So that will be the case like this. Do we really can insert the first row and the third row in our table? How do you think, Yusuf? Can we do that?
I'm sorry, pardon me. Can you please repeat what you have said?
I'm sorry.
I'm still not quite understand.
Okay, let's say that we set this name, the name as the primary key.
Yes.
So it means that in the physical model, it remains the same, right? The primary key of dependent will be the name, right? So it won't have a nib column on it. Am I true? Am I right? Since it won't be a weak entity anymore, so it won't have any foreign key, right?
Yes. That's
Okay.
true.
If that's the case, what if me, myself, and Bu Adatus apparently have, apparently has child, but with the same name, Nina and Nina. My child names Nina and Bu Adatus child names is Nina too. Can we put those record in our table dependence? How do you think? Can we do that?
Well, we cannot
Yeah, that's the
because
reason.
there has. Okay, I understand. Thank you,
Okay,
ma'am.
you understand. Okay, you got the idea now, right? Okay,
Yes.
great. Okay, that's why. Since the main concept of the weak entity must be the dependency between lecturers and the dependents, it also means that there is no dependent who can stand by itself, who can stand by themselves. Each of the record in the dependent must have relation with one record in the lecturer. That's must. If that's the case, it means that we have to put dependency. It will be better, it will be the best option if we put dependency to relate or to draw relationships between lecturers and dependent, because it will give you a more integrity. It will give you a more strict rule just to make sure that your data will represent the exact real world. Okay, that's the goal. Okay, now let's put it like this again. I'll return to our previous model. So it must be the answer. Okay, that's how you can create your model. Is it understandable for you, or I explain it too fast? Maybe should I have to repeat that again?
I understand. Yes.
You can
Okay.
understand. How about the others?
Yes.
Yes, ma'am, it's clear.
Okay, it's understandable, right? Okay.
Yes.
If you still got confused with my explanation, you may rewatch, okay, after I share the record meeting, today's record meeting, okay? Okay, that's how you can deal with the weak entity in the conceptual and physical data model. I won't give explanation too fast. It seems that I will not finish this slide today because it consists of a lot of slides. Maybe I will explain it later. Okay, maybe maybe it take 2 or 3 meetings to give you the basic concept of data modeling. Okay, I think that's okay. Okay, now after you know how to model your conceptual data model, your CDM and also PDM, now you get the concept of constraint, right? Constraint means that it used to ensure your data integrity. As I can explain in the previous example, if we have this kind of case, we cannot put the name, we cannot put the same name on the D name. We cannot set the D name as the primary key of the dependent entity. We call it as a constraint atau batasan ya, batasan or rules. We also call it as a rules or constraint. That's the same. Constraint avoids errors when inserting or deleting data. Okay, that's how. Okay, let's move. I'm done with this one. We also done with this one. You now know what the difference between strong entity and when we implement weak entity instead of a strong entity. We also know this one. Now let's move to the attributes. Okay. There are several types of attributes. Key attributes, also known as a primary key. One or more attributes that have unique values so that they can be used to distinguish data in a row from the other's row. We call it as the primary key. I think that you already got the concept of primary key. I won't describe it more. Let's move to the number 2, single valued attribute. It's an attribute that has only one value. We call it as a single valued attribute. Fortunately, all of our attributes in the previous design is already in the single valued attribute. It is single, 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 and so on. We cannot find there is a lecturer who has to name. Maybe I have an, let's say, nickname. I won't put it in the L name. I only put my full name on this column. So there's not the case that each of these attributes consists of multiple values. No. Okay. And the number 3 is a multi-value attribute. It's a kind of attribute that has a group of values. We will talk more about that later in the next slide. Okay, here's for this case. Let's say we have entity concept about student, and student has several attributes, which are NRP or student number, name, address, age, date of birth, telephone number, and also the email. Fortunately, all of these attributes can give you an example of each type of attribute as previously mentioned. Let's start from the first one, primary key. We know that the nature of primary key can be used as identifier that can identify one record with the others. In this case, NRP considered to be the most suitable identifier for a student entity. That's why we set the NRP as the key attribute, or in the other words, we also set it as the primary key. Okay, I think that you already knew that concept. I won't describe it more. How about the number 2? Single value attribute means that those attributes only consist of one single value. Email, name, address, and so on. That's the example of single value. It also means that for each attribute, for each student records, only have one email address. For each student records, only have one name. For each student records, only have one address for the example. That's why we call it as a one single value attribute. What about the number 3, multi-value attribute? Multi-value attribute means that the value of that attribute can consist of several different values. In fact, maybe we can find in the real world, in our real world, maybe there some students who have more than one telephone numbers. Let's say they have a dual SIM card on his or her mobile phone. If that's the case, we want to save all of his number. So it means that this attribute must be set to multi-value attribute. In the ER diagram, the notation has a double line on it. Okay. As you can see, it has a double line on the notation. We also call it as a multi-value attribute. We will put this aside. I want to give you a basic explanation of the attribute first, okay? We will talk more about the multi-value attribute in practice later. Okay, next, the fourth one is a composite attribute. A composite attribute stands for attribute that consists of several smaller attributes. In our example, it can be represented by address attribute. As we know, the value of address can be consist of the name of the street, or even the house number, or maybe the city where those house resides, or maybe the country of postal code or something like that. That's why we can say that this attribute is the example of the composite attribute. In case you find that your model has a composite attribute, the best step is to decompose. Okay, the best step is to decompose your attribute into smaller attributes. Let's say in this case, address. Let's divide it address into two smaller attributes, such as street name and the city. Okay, that's how you can deal with the composite attribute. Okay, the last one is derived attributes. Derived means that the value of that attribute can be derived or can be calculated from the existing records, existing value. Let's say in this case, I have age as the sample of derived attributes. What it means? It means that in order to get the age value of a specific student, let's say I have student called Andy. Andy was born at, here's for the example, 1 January 1990. That's for the example. In order to know his age, I can calculate from the birth year. Am I right? Am I right? Can
Yes,
you?
ma'am.
Okay.
Yes.
Can you find the Andy's age from his birth date? Can you? Of course we can, right? We can subtract today's year with the Andy's Andy's birth year. Let's say today is 2021. So what is Andy's age?
31.
21. Ah, that's right.
31.
31. So the age can be derived from the date of birth. That's the definition of derived attribute. Okay. In ER, in entity relationships, it can be represented as this oval, but it has a dash on the line. Okay, that's a difference. Okay, we don't have a specific treatment in this derived attribute. We will talk more about that in our next course, in more advanced course called database management system. Management database. You will enroll this course in the next semester. So we're gonna skip with the derived attribute for now. Okay. Okay. After we know there are several types of attributes, now we can deal with the modeling. If you find that your one of your attributes are composite attributes, and it can be decomposed into smaller attributes, more specific attributes like street name, or city. If you deal with this situation, please eliminate this one. So you have to eliminate the address. I'll put this. I'm going to eliminate the address, and then I will directly connect street name and city name as the attribute of the students. Okay, that's how you deal with the composite attribute in the modeling. Okay, let's try it first. Okay, in here, I'm going to create one more entity. Oh, wait. This is physical. Don't forget, start everything from the conceptual, okay? Don't, please avoid as possible create table in the physical. It will be better if you make, if you have to keep the consistency of your CDM and PDM model. That's the best way to make sure your diagram still valid. Okay. Move to the conceptual design. In this case, I'm going to put another entity called students. Let's say we have students. And I'm going to use our previous design. We will have NRP. Let's say it consists of char 10. And since it's primary key, I'm going to check the P option. And the second one is student name. This must be variable character. Let's put 100. Let's say it cannot be null, so I check the mandatory option. And next is what else? Name. Okay. As name. Street name, street name and city, age, date of birth, email. Okay. As street city, street name, as city, and as what else? DOB and age, as age, and what else? Email and telephone. As email, as telephone number. Okay. Street name, I'm going to put a variable character 200. City, variable character 100. DOB, it will be more convenient to set as a date. Age, how about the age? What is the type of age? Which one is more preferable?
Integer.
Integer. I think that's also enough. That's also sufficient to represent the age. And for the email, I'm going to use the same as before, using variable character with 100 length on it. And for the telephone, I'm going to use variable character 15 for the example. Okay. Now we have these attributes. Okay. That's how you can model the conceptual of students. Let's put it aside like this so you can see the comparison. Okay. I'm gonna, okay, like this. Okay. And now how we can deal with the multi-value attributes. Multi-value means that this telephone number can consist of several values. It can be consist of more than one or maybe many values within the records. Let's say now we try to imagine what if we insert new record in the table students. Let's create a new table, a new new seats in here called students. I have NRP for the first column. and also the primary key of the students. Now I have an S name, S grade name, S city, S POV, S age, S email, S telephone number. Okay. Okay, character 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's for the example. Okay. Let's say I have Andy. Wait. It has his address is in Bangalore, let's say. And city Surabaya. POV, it must be indeed. Wait a minute. Oh, custom. CDMMM. Can I create a new one? Yeah. YYYMMDD. Okay. So, like this. In our previous example, I'm going to leave it blank because this is for the derived value. By practice, it can be automatically inserted by our DBMS using several code, but we're not going to implement those now. Okay, we're going to put it aside first. And then for the email, let's say Andy@gmail. And for the for the telephone number, let's say in this case, Andy has two different telephone numbers. The first one is like this, for the example, and the second one is like this. Now, my question is, can I put this one in the telephone number? How do you think? Can I do that? Do you have any opinion? Can we use comma in here? Can we use comma to separate one value with the other value to represent or to put attention to the DBMS, to tell the DBMS that Andy has two phone number? What do you think? Can we do that?
I think yes.
I think no.
I think no.
No, no, we cannot do that. We exactly cannot do that. If in case you found that one of your column, one of your attribute is a multi-value attribute, you have to put more effort. You have to put those telephone out of, you have to move it out from the student entity, and then you can create it as the entity. Let's say we already knew the concept about one-to-many, right? You already know the concept of one-to-many. Instead of have one multi-value attribute, by concept, it will violate the DBMS rule. In order to facilitate the fact that Andy can have two or maybe three or more telephone number, we can create one additional entity called telephone number or telephone. Like this. And then let's say we can put the telephone number cell. The number. Okay, the number like this. Let's say quarter 15. Okay. You have to set it as the primary key or not, it's up to you. But in my case, it will be convenient to set it as primary key, since the same exact telephone number cannot be used by two or more students. Okay, just to make sure that the telephone numbers is private. Okay, here's the case. After you have two entities like this, we can eliminate, we can erase this one from the students attributes. Okay, let's delete. I'm sorry. Wait. Okay, apply. Now we don't have any telephone number on it. Instead, we have to connect, we have to draw relationships between students and telephones with one too many. Let's give it a name. Has telephone number, like this. And just to make sure the cardinalities, you can check these two statements. Each student may have one or more telephones. True or false? Yes or no?
It's true.
True.
Yes. Okay. If it's not violate the true, if it's not violate the fact that happen in the real world, so it must be true. However, the number 2, each telephones may have at most one student. Is that true? May
No.
have at most one.
No.
So it means that maybe there's a number who doesn't have any owner. Oh, it's not the case, cannot happen in our real world. It will be more convenient if we check the mandatory. So the statement will be rewrite into each telephones must have one and only one student, which means that all of those telephone numbers must have owner. Okay. Okay. Okay, there we go. Now we have the telephone number. But it also really depends on your situation. If you put more strict rules on it, if you said that the telephone numbers is, if you said that the telephone's records are dependent to students, so you shouldn't put primary key on it. Okay, that's really depend on your situation. Okay. Okay, now you get the point. Do you have any question? Everything's clear?
I think no.
Yeah, okay, great. Okay, that's how you can deal with the multi-value attribute. Okay. And what if can I generate the physical data model? Of course you can. But before you do that, please check your model first to make sure there is no warnings or errors on your model. Okay, we have one data item that not used in our diagram. We can consider to delete it. You can move to the model, data items. Please find the S telephone in here and then delete that one. Okay. Recheck the model. Okay, now we don't have any warnings and errors. Now we are safe to generate the physical data model. So, okay, generate. Okay, there's a difference if you tick this preserve modification or not. If you tick to preserve modification, it means that all of the modification you manually put in the power designer will be kept by the power designer. In our previous step, we manually insert primary key in the PDM, right? Do you still remember that? Okay. In our previous step, we manually set the primary key of the name in the PDM, not start from the CDM. In that case, if we don't tick this option, the setting will be eliminated. Okay. Let's say I'm going to preserve my modification in my previous step. I don't want to erase the primary key in the D name in my PDM. That's why I have to check the preserve modification. Okay. Let's say okay. Okay, this is how you can merge your model. Let's just click OK. Now, you see the D name primary key is preserved. Is preserved in the is preserved in the PDM. And then your student now, your entity student and telephone, you can see now telephones has NRP, which is also the foreign key of the telephone. It means that we can identify who's the owner of those telephone numbers. Let's say, I'm going to give you some example. Now we have the fourth entity called telephones. I'm sorry. And in this case, we have telephone number as the primary key and NRP as the foreign key. I'm going to put this one just to remind you that attribute derived from the student entity. Okay, telephone number is the primary key. Let's say, oh, wait. I'm going to use this one. Okay, I'll use this one. Okay, and the second one, I'm going to use this one. Okay, and for the NRP, I'm going to use this NRP. Oh, wait. Okay. Oh. Okay. Okay. Your records will be represented like this. And don't forget, we don't have this column anymore. Okay. Okay, done. Using the foreign key, we can identify who is the owner of the of those telephone number. Okay. Okay, is that clear for you, or do you have any question? Do you? Is it understandable? Please give me a reaction if you understand what we discussed today.
Yes, ma'am.
Okay.
Yes.
4, 7,
Yeah.
8, 9, great. Okay, then for the others, maybe you can rewatch our record meetings. Okay. If you have any more question, you can ask from our you can ask in our group WhatsApp. Okay. Even if tonight maybe you try to practice with the Power Designer and you find difficulties, please don't hesitate to ask. Maybe our class assistant will help you, will answer your question. Okay. I think the time is up. We already
Excuse me, ma'am.
Okay,
I
Fatih.
have one last question.
Okay, please.
The power designer is only how to say it, compatible with Windows, right? How about can we use any other alternative for power designer?
I'm sorry, Fatih, I cannot hear you clearly. Could you please repeat that again, or maybe you can type your question in the chat room?
Can you hear me?
I can hear you, but I cannot hear you clearly.
Pecah-pecah. Apa sih namanya? Break.
Excuse me, ma'am.
Okay.
I want to ask, I can install Power Designer because Power Designer is support from Windows
Oh, I see.
operating system,
Okay,
and for
okay.
the Linux and Mac operating system, it can install it.
Oh, I see. Fortunately, we only have a Power Designer in Windows OS. But wait. What operating system do you have?
I have Mac OS
Okay,
and Windows, but the Windows is I must restart my computer so I can change the operating system.
Okay. Maybe that's the only alternative as far as I know, because fortunately we Power Designer doesn't have a version in operating system other than Windows. That's the limitation of the Power Designer. However, if you, in case you don't have any Windows operating system run in your computer, you can use alternative tools such as Vertabelo, maybe, if I'm not mistaken. I'm going to inform you later, okay? But it's only the case if you don't have a Windows operating system installed in your computer, okay? I'm going to inform you in group WA, WhatsApp group, okay?
Okay, thank you.
Okay, thank you. And what about, who gives me question? Fatih, maybe? Or Yusuf?
My question is the same as Denta.
Oh, okay, okay, great. Okay. And how about Fatih? Do you have any other operating system? I'm sorry, any Windows operating system run in your computer?
I have Windows, but same like Denta, I mostly use Linux right now.
Okay, unfortunately, maybe you must do more effort rather than your friends, but I think that's the only solution at this case. Okay. How about the others?
Perhaps, ma'am, the one I use right now is Lucid Chart.
Mhm.
I use Lucid Chart for my ERD.
Lucid, Lucid. Okay. Yeah, that's also the alternative tools that you can use Lucid app. Okay. Yeah, that's also the alternative. However, it doesn't have a feature like what we call it, check model, generate CDM. No, Lucid doesn't have that feature. Okay. If you stick with the Lucid, I'm fine with that, as long as you can represent your model using those tools. However, it will be better if you can run the Power Designer, because it will give you benefits. Okay. It also can what I call it? It also can teach you how to design your database in the right way. Okay. I think that's my answer. But if you cannot start the Power Designer in your computer and you stick with Lucid, I'm fine with that too. That's fine. That's okay. Okay. Is that okay for you too?
Okay, ma'am.
Okay, great. And what about the others? Do you have any more questions before I close this session? No? No questions so far? Okay. I know that maybe today's lecture is quite heavy for you. It's quite, there's a lot of things that you have to learn at the same time. But don't worry, I'm going to share this record meeting in the classroom. Just make sure to recheck that again, okay? Maybe tomorrow, or at least, I'm sorry, maybe Sunday. But if I already shared the recorded meetings, I'm going to inform you in the WhatsApp group. Okay. Okay. I think that's enough for today. Thank you again for your attention and your attendance. Don't forget to try to install the Power Designer, and please try redo our step today. Rewatch the recorded meeting and try it yourself. Okay. In case you have to get familiar with the tools, it will help you with the assignment. Okay. Fortunately, this week we don't have a new assignment. We will get more focused to the data modeling and the concept within the data modeling. So I won't give you any assignment yet, but you have to do some practice. Okay. I will trust you. You have to do your practice before we meet in the next meeting. Okay, I think that's enough for today. Thank you again for your attendance and your attention. And I'm going to close this room, and good evening. Okay.
Thank you, ma'am.
Thank you, ma'am.
Yeah, you're
Thank you,
welcome.
ma'am.
Thank you, ma'am.